Hello everyone, SBG Systems is pleased to welcome you today to our new webinar focusing on mobile mapping, including a testimonial of Gryfn CEO Matthew Bechdol as the highlight of this session. I am Noémie Remilly, Event Manager at SBG Systems, and I will be moderating this webinar today. But before we start, just a little focus on logistics. During this session, you can ask all the questions you want using the private chat box located on the right side of your screen. We will provide you live answers during this webinar. And you can also hide this window for a better display. I will now welcome on the stage our main speaker for this webinar, my colleagues LIAN and Mathieu Peyréga. Hello, good morning.
Hello, Noémie.
Good morning.
LIAN, a seasoned international product manager with over 10 years of experience, boasting a proven track record in managing software products across global markets. She currently serves as product manager of software solution at SBG Systems. Mathieu Peyréga is an experienced professional in the field of surveying with more than 15 years of experience in airborne LiDAR surveying and photogrammetry. He now holds the product management responsibility for the survey-grade products at SBG Systems. Let's now have a look at the agenda. So Mathieu will start with a short presentation of SBG product for mobile mapping, including a focus on Quanta Micro. Then Léa will quickly introduce Qinertia, our PPK software. And after we switch to the main part of this webinar, the interview we recorded last week with Matthew Bechdol, the CEO of Gryfn. But before we start, we will have a first poll question. So it will appear on the right side of your screen and you will have 30 seconds to answer it. So the first question for today is, are you already using SBG solution for your survey application? So it's either yes or no. You still have 50 seconds to answer this question. Okay, let's have a look at the results.
Okay, I see that slightly more people are users already of our products than non-users. I hope that after this webinar, you will be willing to try or adopt our products for your application. So let's start with a short overview of SBG product. And then we will have a zoom on the Quanta portfolio, which is a sub-branch dedicated to mobile mapping payloads. First, a forward on SBG Systems. So the company is based in France, near Paris, and exists since 2007 in the field of inertial navigation products and software. We have 8 offices worldwide, and so far we delivered more than 30,000 products to more than 1,000 customers, so our products are already field tested, in addition to being individually calibrated in the factory. The range of products we offer is quite wide. We have INS, IMUs, HRS, and each product, let's say performance range, has 2 flavors. One as a boxed rugged product and its OEM counterparts. So today I will talk more about the OEM versions, the Quanta Micro, Quanta Plus, Quanta Extra, but keep in mind that all those products are also available as a boxed product if your application requires a more readily usable product. So the Quanta series has three main performance flavors. The Quanta Micro, which is perfect for open sky applications, thanks to its tactical grade IMU and full band, full GNSS constellations receiver. The Quanta Plus is slightly more advanced, as a slightly more advanced GNSS receiver that will allow you to track the signal in better conditions, especially on the ground in mobile mapping applications or urban canyons. And the Quanta Extra with the apogee grade IMU will already offer the ultimate performance you need for all applications, long outages, high altitude, and so on. The product that Matthew Bechdol will highlight in his presentation is the Quanta Micro. So let's talk a bit more about it. The Quanta Micro is really amazing thanks to its tiny size. It's 50 by 37 by 23 millimeters, weighs 38 grams, and still delivers outstanding performances for any type of payloads. It allows dual and single antenna modes, and is easy to integrate with its single connector. Our product comes with free unlimited lifetime firmware updates and unlimited free access to support team. So this is really important when you want to dive into an integration, to know that you will get support from the manufacturer, and this is what we really want to achieve and help you succeed in your applications. So the Quanta Micro, as I already said, a single connector, which delivers wide connectivity with 3 serial ports, Ethernet, sync in, sync out, and we have also different type of sync mechanism, PTP, from modern LiDARs, which offer this new way of synchronizing the measurements, and also the legacy PPS and event mechanism are of course supported. We have an internal 8 GB data logger that will allow for a smooth recording of the raw data that will further let you do some post-processing with the software Qinertia that Leah will showcase a bit later. The main performances of the product are the centimeter position accuracy in PPK and RTK, and the 0.035 degree heading accuracy in PPK single antenna mode that we can achieve with this product. So this is really perfect for UAV applications. The product can come with a development board and evaluation board that will let you quickly access the connectivity with standard connectors like RG45, DB9 for the serial ports, and also the antenna, GNSS antenna ports. And we'll let you have a quick start into your integration, especially for the software parts, and do all the testings you need. We can also deliver you some antennas, GNSS antennas. For UAV application, we have this UAV helix antenna, which is really amazing and lightweight, but for other applications, we can provide you with any type of antenna. We have a wide catalog. Please get in touch to get more details. The Quanta series, as all products in our range, comes with a full software ecosystem. So the SBG data logger and entry client can be used on the desktop in addition to the internal data logger or for some specific configuration. We have the SBG Center, which let you have a real-time analysis of the data and flags the navigation status and so on. We have a C libraries and samples for the software to decode our proprietary but still open and fully documented protocol for the data in output of the units. We can of course also output data in standard forms like NMEA and so on. And last but not least, the Qinertia post-processing software, which will let you get the most out of the product for your surveying applications. And I will let Leah, our product manager, talk more about it now.
Okay, thank you very much, Mathieu. So before we go further on Qinertia with Leah, we will have a second poll question. So the question is, what georeferencing method do you use for your UAV surveys? It could be PPK, RTK, GCP, or another method. You have still 15 seconds to answer this question. Okay, let's have a look at the result.
Okay, we got an equal record between the RTK and the PPK. Indeed, RTK is a reliable option for the real-time correction, and also PPK can provide like another solution when the environment with poor signal reliability or the GCP is not practical. So now we will discover Qinertia together. So Qinertia is the post-processing kinematic software. It can improve the accuracy of GNSS position data by correcting the error after the acquisition. Qinertia has a modern, user-friendly interface. In tissue designed to quick learning and have an efficient use, ensure seamless experience for all the users. Wide compatibility. It can process data from a variety GNSS receiver manufacturers, supporting full band and full constellation coverage, and integrated data from initial measurement units to ensure positioning correction, compatible with SBG products, and also a list of a third-party IMU with error model and a generic format. Actual data from sensor can be supported. For example, we can support automatic, magnetometer, and DVL. For the quality indicators, various indicators to assess accuracy and the reliability of processed data, flexible export solution to ensure that transparency about how you seamless integration with the downstairs software for the further work, and some option for the HTML PDF report. It's customized, like you can choose which section you want to add inside and easily to share with your client or partners. We have a motion profile enable it to handle the data from different applications like air, land, marine, statistics, and a special pedestrian mode. So it's very useful during the application like a backpack application when there's very low velocity, very low dynamic. Qinertia will recheck the installation of all the sensors to make sure all the misalignments is already corrected. A small tool for the learning arm estimation that can help you increase your process of your measurements. And when we go to the processing mode, we have several options. Like you can download the data directly from the SBG server with a free list of the published free data. And also you can find some pace course network that you just enter the correction data that can become a data. And also if you have a personal installed base stations, you just input the RTCM Renex data into Qinertia that can become a base. We can use it to do the PPK with a single base for the short baseline. When we do the corner mapping, the functionality of the virtual base station can be useful. That will build a virtual base with a network of base station around. And when you are in the situation with very high ionospheric activity, the new algorithm IonoShield will mitigate all these effects to make sure you have a good result. And another option is a near real-time PPK. We just processing with RTCM stream, so you don't need to wait for the available of the base station. Just launch it after the acquisition. And when there's no base around or you're like in the middle of ocean, you can use the PPP with just processing with a signal from satellite. And a model of a photogrammetry help you do some geotagging, export invite file. Geodesy engine is a built-in library, so it's included over 5,000 coordinate reference systems, which can handle the transformation between different datums. So you just choose the export datum to make sure your project is corresponding to the local datum. And with the advanced GNSS setting, you have the possibility to check all the quality of the satellite. Like Qinertia, during the processing, it will remove the poor quality satellite automatically, but you also have the option to manually do it by yourself. Qinertia is a software for all users. Whenever you are an individual user, a company user, a system integrators, a software editor, or a service provider. Like we have the desktop version that can very useful with a graphic user interface. It's easy to input the data, do some analysis, and export the data you want for the individual users. And when you are a software editor or you want to enable Qinertia as a model of your software or your service, you can choose the version OEM or the cloud API that can use the technology of all the cloud-based. And we provide free demos online. So you just leave your email here. So we will get back to you to provide some free demo, and it will be followed up by 2 weeks free demo license. So that's all my part for Qinertia. I will give screen back to Noemi. Thank you.
Thank you very much, Leah. It was very interesting. Before we switch to the main part of this webinar, the interview of Matthew Bechdol, the CEO of Gryfn, let's have a last poll question. So the question is, what payload do you use? So for survey, do you use these following payloads? LiDAR, RGB cameras, hyperspectral camera, or another type of payload? I'll let you answer, and then Mathieu will comment on the results. Okay, thank you for your answer. We will discuss now the results with Mathieu.
So that's nice to see that you use all types of payloads. I would be interested to know what are the other types of payloads that you use. Please tell us in the chat. You will see in the presentation by Matthew Bechdol that they are using actually all those types of payloads and even more. So our products are perfectly suited for that. So I will now let you with the recording. He's really passionate about this application. The application is amazing. And the part where he talks more about the product, the SBG product, and how SBG helped in succeeding in the application is more at the end of the video. So please stay with us until the end.
Hello, everyone. We're today with Matthew Bechdol from Gryfn, who has to share with us his experience of SBG products, or at least the SBG products that is using with his company. So, Matt, can you start by just presenting yourselves, and then I know you have prepared a very nice slide deck to showcase your activity.
Absolutely. I appreciate the opportunity to be here, Mathieu, and talk with your team. My name is Matt Bechdol. I am the CEO of a company called Gryfn, and we work with remote sensing and drones, several spaces, but primarily agriculture. For the audience context, my background is in applied science of remote sensing and geospatial applications, with a business and economics background, not engineering or survey background.
Yes, that's very nice for us to also see our products used slightly on the corner of the surveying use case that is our traditional audience. So I hope that this will be interesting for everyone and new users. Yeah. So do you want to jump into your slide deck right now? And I will, if you are okay with that, I will try to ask the questions if I have some in the middle of it.
I would be happy to. I prefer a conversation. That would be great. So we'll get started. And again, I'll start a little bit about, where we came from and why we do what we do, and then I'll talk about how we implement SBG. First, we focus on premium remote sensing solutions for research. We focus on the research market, and that's important to state because with the research market, there are a completely different set of expectations around precision, around accuracy, around repeatability. There's also a different level of tolerance for difficulty and complexity and price, integrations, those kinds of things. That research market is a very different segment than maybe a traditional consumer market, for example, that you might see with the drone or imaging space.
And also from the survey market, the surveyors market.
Yeah, from the surveyors market. And obviously with the surveyors market, precision and accuracy are critically important as well as repeatability, but with just a different kind of approach and different kind of attitude about how they approach their work and workflows. And again, our work was primarily coming from agriculture, and I'll talk a little bit about that as to why. But we started from a Department of Energy grant here in the United States with a multidisciplinary team focused around what we call plant phenotyping. And I'll talk about that in just a moment. What's important is, again, it was multidisciplinary. We had civil engineering, biology, plant science, computer engineering, computer science, ag bioengineering, multitude of experts coming together to try and address this problem, which is why to this day, most of our work remains in agriculture and agricultural research, but our tools are broadly applicable to lots of applications.
So if someone today is interested by your tools outside of the scope of agriculture, do you support it, or do you prefer that they go to see someone more on their market?
No, absolutely. Our tools are domain agnostic. That just happens to be where we came from. It happens to be where we have credibility in terms of word of mouth of people using our tools and knowing what to expect. There's also, as I'll talk about in just a moment, there's this unique use case for what we call multimodality and having multiple sensors, but it's not the only one. We have users in the environment, in forestry, even defense and intelligence applications. So these tools are broadly applicable. It's just a little bit of where we came from and what we are known for.
Okay, I see.
So plant phenotyping, in the short version, is really about how do we take seed genetics and we put that seed into the environment, and that environment is different around the world. And as we know, the world is changing. It's getting hotter, it's getting colder, wetter, drier, and keeping up with those changes as we try to feed and fuel and clothe the world is very difficult. So plant breeders have to do generations and generations and generations of these plant trials. And phenotyping is really about the observable characteristics. And to do that, traditionally, it's by hand. PhDs are in the field, they're measuring things, they're counting things with sticks, with tape measures, lots of students. So it's slow. It can be dangerous because of the heat and some of the conditions. It's obviously labor intensive. It can be highly subjective. Mathieu's recommendation of a disease rating of 4, for me, might be 4.2, 4.5. And from a science perspective, that's not what we want. We want something repeatable. So the challenge was, how do we use sensors and sensing to address these? How do we scale? How do we make it faster? How do we make it less subjective? And over time, how do we bring down costs so that we can improve the speed and quality of plant phenotyping across time? And this is where we get into what we call multimodal sensing. And so here's just one example. So this is maize. Here in the United States, we grow a lot of it, probably too much of it. But as you can see in this bulleted list, we don't need to go through this. For those of you that aren't plant scientists, which I assume are all of you, there are different things that they want to look for depending on what they are growing the crop for. It could be plant height. Maybe they want it tall. Maybe they want it short. Maybe they're feeding it to animals, so they want a lot of biomass, but they don't need a lot of grain yield. Maybe they're worried about the plant falling over early before they get to harvest. Each one of these things requires a different type of observation in the field. Some of them are physical. So you want a 3D model, if you will. So we use LiDAR mapping to say, what is the height? What is the biomass? What is the penetration of light in that canopy? Some of them are chemical spectral. So what is the vegetative health? What is the unique spectral signature of light that interacts with that plant when it has a disease? So we use things called hyperspectral cameras, which are advanced multispectral cameras that we use. They use energy beyond what our eye can see. And some of them are things like just patterns. So RGB cameras, much like on your phone, where we take a picture and we use machine learning or artificial intelligence to count things like little tiny flowers or particular things that we want. No one of those modalities gives us everything we need. And so we want to use multiple modalities at the same time, because getting in the field, getting in the air, and getting that data is very difficult to do, and it's time consuming. Well, here's just a couple of quick examples. So in this case, RGB data, where growers or researchers will actually want to count those little yellow tassels in the corn. It's very important. So one of the biggest drivers of yield is the environment of those tassels during pollination at night is critical to yield. And so it's such a narrow window of just a few days that are critical in that research. So they want to say, How much area is in there? How long are they? How spaced are they? So this is where things like RGB data are really important. They also want to look at the spectral signatures. So in this case, this is what we call a hyperspectral cube. On top, this is what our eyes would see. This is red, green, and blue, just like our eyes or your iPhone would see. And then on the sides is a representation of all the sources of energy that we look at with this camera. In this case, this one looks at 270 slightly from 400 nanometers, which is in that blue range that our eyes see, all the way out to 1,000 nanometers out into the infrared. These are important slices of energy we look at to look at crop health. And then you look at LiDAR. And again, LiDAR is something that from a surveying perspective is much more intuitive. We use these tools like SLAM and things like that for pits and mining operations or other kind of modern mapping. In our cases, we're using it for biomass and height. In this case, we've got a drone LiDAR that's flying over the field. And now we've rotated that three-dimensional space. So it's like we're doing a virtual tour of that field. And we can look at the different plants and look at their height. We can look at their canopy structure. We can understand, oh, we're interested in the organic market. Is light penetrating that canopy to shade out those weeds so we don't have to use herbicides and those kinds of things? So it's really important to have all of these data sets combined to give us that information. And then finally, the important part that starts to get us to this positioning and SBG role, time is critically important. It's not just one image. So when we do this research, we have to look at the same field, the same research plot, and our goal is essentially creating digital twins at the plant scale. So multi-data alignment, the ability to just do instant research, to have the precision and quality to do that at the plant scale is critically important. So in this slide, you see sorghum collected over multiple dates. So we can run our models over multiple dates without having to manipulate the data. It comes off the drone, it goes through our process, and it goes directly into the models. And this is what enables us to do what we do.
It's really interesting to see all these applications of the sensors that most of our customers use independently, but to see how combining them gives so much knowledge about the plant health.
Yeah, absolutely. It's the critical piece. Again, all of these components are valuable by themselves, and even a researcher standing in the field with their phone taking a picture is valuable. But when you combine them and you can do them all at once and you can do them at a high level of precision, and then you can what we call co-align them so that you're within a couple of pixels, within a couple of centimeters of accuracy of all of those modalities, it's critically important. And this is where we start to transition into the value and how we use SBG. And so, again, this slide I don't need to go through, but these are some of the value propositions of why that multimodality matters. But the secret sauce of that is the GNSS, it's the GPS, it's the high precisioning and accuracy. And so when we frame things, and I'm going to come back to this very same slide at the end, but through the lens of our relationship with SBG, when we frame what we do for the customer, we try to do four things. One, we try to take the lab to the field, meaning what we do now in plant research, a lot of the modern techniques are done in the laboratory because it's a perfect condition. We can monitor it, we can light, we can image, we can water, we can fertilize, we can do all those things. But we can only do dozens or hundreds of plants in a day. We need to go to the field where there's tens or hundreds of thousands of plants. So that's incredibly important to bridge what we're learning in the lab with what we can do in the field. Number two, we need to make it easier to use. So we're talking about research tools. So we're talking about multiple cameras, multiple instruments, all integrated into one tool. If it's not relatively easy to use, that negates the time savings, it negates the value proposition. So it has to be relatively easy to use. But again, as I introduced to begin with, this is a research community. So they are accustomed to complexity, but that doesn't mean it's acceptable to make it hard. Complexity is one thing, but it still should be easy to use. The third thing is delivering quality, precision, and repeatability. If we can't do that every single time, then you undermine confidence in the protocols and the research. So we have to be able to do that. And then finally, we want to shorten the gap between acquisition and analysis. traditionally our commercial market, our consumers, our users are more concerned about time than our research markets in terms of university, academics, etc. But that's changing because they're recognizing that in the past, it was not even a possibility to do these things quickly, so they didn't try. And now that they can ask different questions in the middle of the season. So these are the ways that we frame these, and this is also the way that we frame the relationship with SBG.
Yeah, and I guess it also allows to tune the acquisition plan that you presented a few slides earlier, like when you do this multi-date alignment. Maybe you can skip a flight if you already have the results from the previous one to just do what is necessary. So you have to process everything quickly.
That is correct. Absolutely. And again, in some of these crops, the window of opportunity to image them at the type of maturity is days. And so if it rains, if it's cloudy, if you can't get that image, but you found out what you needed to find out in that image before, then yes, absolutely, you save time and money and you can move to a different location. So real quickly, I'm not going to go through all of this. We do three primary things. One, we do not build sensors. We do not build drones. We integrate multimodal systems. So we take the best on the market systems and cameras through partners like SBG, like Headwall for hyperspectral, like Ouster for LiDAR. And then we build the integration components, the firmware and the software to operate those. So in the top right, you see our newest Gobi system. Our objective with Gobi was lightweight systems that are high-powered, high-precision machines. So this is a LiDAR hyperspectral RGB system that is only 2.6 kilograms, which means medium and heavy lift drones can operate them. So it opens us up to a broad range of research customers. We also create our own software. So we process everything from every sensor that's on board, and then we rely on partners like SBG to do the GNSS processing, but we streamline that through our workflow. And I've got a slide on that in a little bit talking about how we do that. And then lastly, we do what we call drone as a service, which is basically we fly for other researchers. And we do that for a couple of reasons. It started off to just test our own equipment. And now we're finding that consumers, when they have scale issues and they maybe can't complete everything they want to, they bring us in to help. So that helps us really test our own equipment, which means we can provide those lessons right back to the users. So here's just another picture of Gobi to give you an idea. For those of you that are not around the drone space, on your right is a relatively medium-sized DJI. Many of you have probably seen the DJI little white drones that you can get. They're very inexpensive, very fun, make high-quality videos, are great. This one on the right is a little bit bigger than that. The one on the left is an Alta X made in the United States. These are Hollywood platforms. So these were started in Hollywood to carry the big cameras for Mission Impossible and some of these kinds of movies. The reason we went to them is because of that reliability of heavy lift. Some of our other platforms are much, much heavier. So we have built platforms where the total takeoff weight is in that 25 to 26 kilogram scale. These are big, heavy sensing machines on the order of $350,000 to $360,000 US. Much, much more expensive than our Gobi. But those are flying laboratories, so you need a big, heavy drone. But this is just an example of what these very small payloads look like on these big drones. And then just a couple of specs. For most of you in the surveying industry, you're probably not interested in these, but just to give you an idea of kind of what these things look like and some of the ranges, some of the megapixels for those of you that are more used to RGB cameras. These are high quality sensing tools that, again, we integrate to co-align the data. And then again, our software is critically important to streamline this process. So again, we process the RGB, the hyperspectral data, and the LiDAR, and then we integrate directly with the SBG products to take that trajectory information as an input to our outputs. The next thing here's that slide, and go ahead, Mathieu, you have a question?
Yeah, I'm quite used to the workflow for LiDAR or RGB, but for the push broom, I think you're quite a unique customer of ours using this type of sensors. Was it, let's say, seamless to integrate the SBG outputs and protocol with the push broom, or did you have specific challenges that you had to solve?
So
I know you're not on the engineering part, but that maybe you still have clues.
No, but I am on the business part, and so I have asked my developer this question multiple times, and his answer was that it was a fantastic experience, that it was seamless, it was easy. Now, with the caveat of obviously we have been doing this for several years, and so we had worked out a lot of the kinks around how to best do this in the past. But for us, transitioning from some of the other tools that we had used in the past to SBG was a matter of days. Not weeks, not months, days. It was a seamless transition.
Okay.
And for those of you that aren't aware of this concept of push broom, I'll talk about that in just a minute. This bore site calibration component, I'll come back to in just a second, because this is that secret sauce that SBG allows us to do. So in a very simple sense, here's kind of the workflow. On the left side of the slide, imagine that you're in the field. And I don't have a drone picture here, but you're flying a picture, you're on the drone. And on the right side of the field, you're in the lab, you're in your office. So we fly a mission, and that mission is relatively short. On the payload, so on that Gobi, there are all the cameras. There's also a mini Jetson computer from NVIDIA. That handles a lot of the transactions between these sensors. And so we have a Gryfn embedded software sitting on that Jetson payload that's communicating with the cameras independently. So it communicates with the SBG, it gets the information that it needs, all the files, it communicates with hyperspectral, it communicates with LiDAR, and then through one single FTP connection, it pulls all of that data off onto a field computer. That field computer then has all that data set, and it takes it into what we call our Gryfn processing tool. And the Gryfn processing tool has really just three very basic steps. One is we call a bundling step. We take all the data, we put it into essentially human readable folder file structures, and this becomes your source of truth. It becomes your data archive. It's checked for data accuracy, it's checked for purity, and then it can be used as not only an input to your outputs, but as a archive data set that you can come back to at a later time. And I won't go through all the intermediate steps, but the next step is we create what are called pipelines. Pipelines are basically recipes. I have this camera, this camera, this camera. I want these outputs, and I create the little recipes that I want. And then those are output into these final kind of data folders and structures that are all non-proprietary. So we call them research ready. So if you're using open source tools, you're using homegrown tools in Python, you're using commercial off the shelf, the data sets will all work. Essentially what's happening though as a part of that process is that one of the key inputs is obviously the Qinertia. And so we kick off an inertia through the command line interface to get the information that it needs through the boot process. And then we have a custom events.txt file that we get back out because we want the data structured in a particular way. And to Matthew's question, that was really the only quirky thing that we really needed because it had everything already built in. So we just needed this custom data set in a TXT format that we already knew how to handle. Qinertia gets us that information right back into our software. The customer never even has to interact with Qinertia unless they need to because they want to intervene. So I'll come back to that in just a second. But for the consumer, this process is very, very short. So I come back to those recipes. For most of our users, they tend to follow the same protocols. So if you go back to that sorghum field, they flew that 8-9 times. Once they set up that process, all they're really doing is pointing to the new data sets, and those things get rerun and rerun and rerun. So the user isn't using our software very much. So it's a wonderful user experience because that's streamlined. But from time to time, maybe something happens. Maybe the user spent too much time on the ground before they took off, and they want to investigate. And they could go into Qinertia and they could do that. So that's a high-level overview. Mathieu, did you have a question?
No, I just wanted to say that it's nice to see that I guess your end users are not really interested in the trajectory data by itself. So you are like hiding this part, which is not where they feel the added value from your product, but still get the high level of quality and accuracy that is needed to actually get the added value out of your sensors. So
correct.
It's nice that
Yeah,
you were able to do that.
We kind of joke, and sorry, you're falling into this. We joke that we don't want our users to use our software. They're busy. They're PhDs, they're researchers. They're supposed to be doing research and analysis. So the less they're using our software and the happier they are with the results, the better off they're going to be. So the less interaction they have with us means they're doing more work somewhere else. But from time to time, and for us, it's maybe 1 out of every 15 or 20 flights, you do have to open up Qinertia. You do have to look at the trajectory. You do have to maybe edit a little bit because a new user or a new pilot maybe did something wrong or didn't quite follow the protocols, and you have to adjust that data just a little bit. But it is pretty rare.
Yeah. So just so that it's clear for our listeners, Qinertia offers the two modes of work. One is through CLI, so it can be automated and run under the hood. And we also have a traditional user interface where they can show the trajectory on a map, fine-tune every parameters with a nice human interface and so on. So you are actually using most of the time the automated one, and only like for troubleshooting if needed or special cases the other one.
Yeah, absolutely. So for use cases like ours, where you expect to repeat the same process over and over and over again, it's a wonderful seamless integration. And so the user knows it's there, it's on their machine, and if they need it, it's there. But the less they have to work with software and they're still getting good results, the happier they are. So it's a wonderful relationship, and it works very, very well. We've been very happy. The other notes too, and I'll kind of reiterate this at the end, user management, organization management, the authentication process is simple. It's easy to use. And for us, we've got a mix of users where you've got individual users that are sitting in a laboratory, and then you've got collaborations where you have multiple platforms and multiple pilots, and being able to keep all that licensing straight is really simple with the product. And so we've been very happy. So getting to some of the more interesting things and the things I'm most unqualified to really talk about, but at a high level. So the positioning and orientation of the aircraft and the sensors is critically important to everything that we do. So that quality, that repeatability that we get from SBG feeds into everything from start to finish. And in some ways, it's that if you think about a movie, you know, it's the actors that get all the money, it's the actors that get all the TV interviews. But it's the crew, it's the lighting, it's the sound, that's what makes the movie. And it's the SBG that makes this work. Without it, we don't have the quality product, we don't have the quality experience. And a key part of this is what we call bore site calibration, and how that feeds into what we call direct georeferencing. So the first part of this is called bore site calibration or system calibration. So here we are in the air, on a moving platform, looking down at the ground with different sensors, and we have to map that position on the Earth relative to what is being seen in the camera. So we have to determine the relative position and orientation between each sensor and the GNSS unit. So the SBG relative to the platform, relative to the cameras, and what it's seeing on the Earth as it's moving across time and space. And then as we do that, we're able to do direct georeferencing. So we obtain, based on that trajectory information, through the GNSS, that positioning. A lot of our users traditionally have to use what we call ground targets or ground control, meaning they put out targets in the field. For you surveyors, you would go out with your RTK surveying instruments. You'd go out, you'd survey your points, you'd note those points, and then back in the lab, you would process your imagery, and you would tie your imagery back to those points. So it's a labor-intensive process, and it's also subjective. So how many points do I really need? Can I get points inside of my area? What if I'm mapping water? How do I put a target in the middle of the water?
Or I guess in the middle of a corn field.
In the cornfield. So that means now as a surveyor, and you know the math well, I have all my points on the outside of my subject area. So I can't control the accuracy and precision inside of my subject area. This is really challenging because that precision and accuracy matter, and I don't know what the platform is doing. So by using georeferencing, we can get 1 to 2 centimeters, sometimes better accuracy across the entire area, and you don't have to use targets. This is critically important for research. And so that benefit, we have seamless alignment with data that are concurrently acquired. So RGB, hyperspectral, LiDAR, and over time, and no ground control. And so it's a wonderful value to the customer.
And so this is only possible when you have an INS in addition to the GNSS, because the INS will be responsible for the angles, the attitude angles. So a lot of, let's say, legacy systems only have the GNSS, and with only GNSS, you will always have to rely on GCPs, ground control points, like you explained before.
Correct. Yeah, and again, we still face this as a conceptual leap for a lot of people, because they think about GPS and they think, oh, I have a good GPS. I paid a lot of money for this GPS. It's highly accurate. But they don't understand the difference between position and orientation and the complexity, the value that it brings, the cost, frankly, that it brings, not only in hardware, but in software and complexity. So those are something that we in our community still have to educate about. Okay, you're going from this $5,000 system that isn't getting you very good results, but yes, it works, to something that is much more expensive, but is research quality. And so again, this is just a really nice diagram that Jill, our civil engineer, put together, where you've got the XYZ frame for each camera and the GNSS of the SBG. And so you're looking at the trajectory, you're looking at the relative position to that and the cameras, trying to then back project. So you've got the intrinsic and extrinsic parameters that we use as we go through the process of system calibration. And so Mathieu mentioned a line scan camera. So the RGB camera, and if any of you have been around a multispectral camera, traditionally they are a frame camera. So much like your SLR camera or your iPhone, you have a frame. So it's an XY dimension, and that frame is instantaneously captured. And then with a LiDAR, obviously you've got either a pulse of light or a spinning pulse beams of light, and you're capturing those beams. With a push broom sensor, you're actually only creating a beam that is 1 pixel wide. And as that pixel continues across the space and over time, it is continually stitched together. So it is like a broom that you are pushing and you turn around and come back. And that's why we call it a push broom sensor. So you get 1 pixel wide by whatever it is wide, 640 pixels wide. The light comes through the camera. It is split by the prism and by the grating into the number of wavelength bands that you have. So in our case, with the newest cameras, 340 individual bands or sections of light from 400 to 1,000 nanometers. But again, 1 pixel at a time. So the mathematics and the dynamics of that, you have to do that for every single pixel as you go, as you reconstruct that. So what we do when we do a bore sight calibration to take those intrinsic and extrinsic parameters is we fly a pattern over known targets, 2-dimensional targets on the ground and 3-dimensional little, what we call huts, that are basically just boards that come up like an angle. We fly them at different speeds, at different heights, and at different spacing to improve the robustness of that bore sight calibration, which allows users to have one calibration. And then when they change the dynamics of their flight orientation, that bore sight calibration is good for those different orientations or different parameters or different characteristics. Whereas traditionally, you might have to do that every single time to match your flight height, your flight speed, et cetera, to get the best quality data.
You've got a kind of factory, it's a kind of factory calibration that just needs to be fine-tuned or revised slightly, like with aging, I guess, or if there is some maintenance on the system. But
correct.
Okay.
Correct. And that's that last slide. So on average, it's about once a year, unless there's a hard drop or something like that, or something else happens that the camera needs. But in general, it's about once a year that happens. The RGB is the one that is the most susceptible There are so many parts, especially with differences in temperatures and focal lengths that change. So with the RGB, not only do we do a bore sight calibration at the factory level, we actually do an interactive mathematical bore sight every time we process the data to try and fine tune it.
Okay, and for the other one, is the customer, the end customer, responsible for doing that, or do you return the system to your factory and do it yourself once a year?
So the customer typically returns it to us. We fly it, and then we return them the camera and the bore sight calibration. For some customers that are international, that becomes difficult, especially if they're still trying to use it year round. So for example, we just deployed an ecosystem of sensors to Australia, and that's just not good. They have sophisticated survey equipment. And so what we're doing is we're teaching them how to build the targets, how to fly the patterns. They're going to send us the data so that we can process the bore sight calibrations for them remotely. It saves time, it saves money, it saves risk of shipping things around.
That's
and so, I'm sorry, go ahead.
This fixed bore sight is a very nice feature of full integration systems where you don't dismount any sensor from one another like you had in the past with a bigger system in planes and so on, where you needed to redo that for every flight because this calibration was broken. So this is really, I think, a really good advantage of integrated systems proposed by integrators like you to the end market. That removes a very large operational constraints. The hydro surveyor, they call it the patch test. You call it the bore sight, but if you have to do it only once or a year instead of doing it at every mission, this is really saving time and money to everyone.
Yeah, absolutely. And again, it's imperfect. The more tightly you couple the GNSS and the systems, the less you have to worry about bore sight once you've had it done. The downside is the more tightly you couple it, the more likely you are to have bigger problems when one thing goes wrong. So we're trying to find a balance between those two. And then just for those surveyors that need a math equation in a couple of the slides just to see it, but just to give you an idea, again, I mean, for LiDAR, for the frame camera, you have the GNSS, the body frame, you've got the camera as we're moving through space. We have to take those parameters. And then for the frame camera, and again for the line scan camera, and then reconstruct that data set for the user so that they have those research-ready products. And again, the objective is to determine that bore sight and lever arm for each sensor, and then really align those data. So on this slide, you see a strip of LiDAR from the same one flight, strip 1, and then a second flight, strip 2, and we need those data sets to align so that you have very precise alignment from flight to flight, and then obviously from time 1 to time 2. And this is really critically what's important. And so as I wrap up here, and we can kind of open this up to a conversation, I'm going to come back to the slide that I used earlier, but with a little bit of different kind of take. So you still have the 4 kind of big topics that I talked about with taking the lab to the field, making it easier to use. This is how we frame everything that we do for our customers and how we provide value. But in this case, it's through the lens of SBG. And so with SBG, we had a smaller form factor. So a year ago, we embarked upon this Gobi idea of how do we create a smaller form factor? How do we create a little more agility? How do we think about the licensing? How do we think about the price points and the economics? How do we provide this lighter weight, high powerful platform for a wider audience? And SBG came the clear key to that in about October, November of last year. And that's when we made that position, and we're delivering multiple systems now. Making it easier to use. To Mathieu's question earlier, it was such a quick and easy implementation for the dev team. They were very happy. It's essentially seamless for the user. That the install process is simple with Qinertia. The authentication process is simple. They've got the full suite of tools there if they need to identify any issues, those kinds of things. So that part has been great. We've had relatively limited support calls, but they've been fantastic, and that's been helpful as well. Mathieu, do you have a question?
Yeah, I have many of them, but one thing that comes to my mind is about, let's say, where our intelligence or SBG added value start and stop? Where is the limit that you are expecting? For example, is the boresight calibration algorithm and that type of stuff something you want to keep on your side, or do you expect that SBG also offers it? What was your expectation when you came to us? Are you happy with that? Do you think this is something you are willing to leave us doing it for you, or do you want to keep it your secret recipe? Because I guess it was not that simple to develop, but yeah, you see the point, I guess.
Yeah. So I mean, first hardware. I think the hardware form factor, the repeatability that we're getting in our boresights, again, at the stated level of precision every time that we fly. So that's number one, most important. Number two, for us, one of the big issues traditionally has been the challenges of installing the post-processing software like Qinertia, but not Qinertia because it solves the problem. In many of the customer environments that we have, IT or IS network challenges are critical. They don't have a lot of latitude in terms of administrative privileges. They don't have the ability to install software across multiple networks. So in collaborative environments, actually the software installation becomes one of the biggest challenges. Forget multi-setting, multimodal sensing, forget boresight calibrations. They can't even get the software installed. And the Qinertia process of having that installed locally without needing the administrative privileges and then being able to make a single call for authentication and then having that be stable really has made the life of the install process for the consumer easier. So that was number two, which was really important.
That's where we put the most effort, but we are very glad to know that helped you so much.
Yeah, I mean, again, sometimes it's where the thing you least expect that provides the most value, but we recognized early on, hey, this fixes a problem for us because we were spending almost 25% of our time on support just dealing with installation network issues that had nothing to do with us. It was typically IT support issues, and this has helped dramatically. And then, the third part was economics, and this gets back to some of my other points, but what we're finding is that the total cost of ownership for a 3 to 5 year process for our customers is significantly lower than our traditional solutions have been. I won't go into a lot of detail on that, but it is significant, and that provides a value proposition and a sales point for us, for our customers. So they're very happy with that. And then the last thing is to maybe future looking to your question. Would we be open to continuing to push the envelope on other solutions like boresight or other things? Absolutely. How do we continue to get better quality? How do we make for a better experience? How do we lower the burden on us or on our user? I think we're always open to those things. Yes, right now we have a pretty sophisticated system and approach because we have a pretty unique platform and unique use case because of the multimodality. But over time, that will become more normal. So yeah, definitely something that we would look into over time. Getting back to the slide, just wrapping that up. Again, delivering quality, precision, repeatability. We've had no issues there. Check, check, check. I mean, that's been working seamlessly. It's been fantastic. And then again, shortening the gap between acquisition and analysis. That customer experience has been fantastic. So again, framing the SBG experience, the way we integrate, the way the users are seeing this. In the same way that we do with our own products. It's been a wonderful experience for us so far. Again, we started this process a year ago. We technically delivered our first system at the beginning of this summer, but we really did that as a learning experience because it was a customer that was close geographically to us. And now we've been pushing out the rest of the systems this fall. That was batch one. Batch two, we're making a few final changes to our circuit board and how we implement and how we move data and those kinds of things. So that in 2025, we're pushing a lot more of these. So it's been a wonderfully successful implementation, and we're appreciative of the support and guidance that the SBG team has provided.
Thank you very much for this very detailed presentation, Matthew. I'm glad I mean, I was almost useless there. You explained it so well. I had very little question to ask because your slides were showing it all. Yeah, I hope that was also interesting for our audience, and we're glad to let them contact you if they have some interest in your products, and if they are convinced that we can also help them in their own workflows or projects. Feel free to contact SBG, and we will be glad to provide you the highest level of support that we can to make everyone a success in their tasks.
Yeah, absolutely.
Thank you again, Matthew.
Yeah, thank you. And again, we always appreciate the opportunity to talk to an audience that isn't our audience. There's always opportunities to learn, especially with the surveying community. I came from the GIS community, and I remember the days where the GIS community and the surveying community did not talk to each other. So it was rewarding to see those communities start to spend more time together. And in the same way that we're seeing it, especially in things like mining, traditional surveying and mapping, with now more drone and remote sensing mapping, and merging those communities together. We have slightly different techniques, but our language is geography and data. And so it's exciting. So we're happy to help, and we appreciate the opportunity. So thank you again.
Thanks. Bye.
Bye. Cheers.
So we are back to live. We thanks Matthew Bechdol again for his time and for sharing with us his experience of SBG solution on his daily application. We thank you also for joining us today for this webinar. Please note you will receive a recording of this session in a few hours. You will now find on our screen the contact detail of our different teams all around the world. So don't hesitate to contact them if you have any questions. We thank you very much again for your attendance today, and we hope to see you soon for another SBG Systems webinar. Stay tuned. Bye-bye, and have a nice day, everyone.
Bye.
Bye, thank you.